Good morning, distinguished judges, respected participants, and everyone joining us today. We are Envirentara, a team from the Environmental Engineering Department, Universitas Islam Negeri WALISONGO Semarang. Our team consists of Vaza, Yusuf, and Eva. Through scientific innovation and evidence-based research, we are committed to developing sustainable environmental solutions for a cleaner and greener future. Today, we are proud to present our research entitled The Potential of Rice Husk and Pine Wood as Raw Materials for Low-Emission Composite Biomass Briquettes. Global energy demand continues to rise in line with rapid population growth and industrialization. Unfortunately, reliance on fossil fuels continues to drive greenhouse gas emissions and climate change. Indonesia has an abundance of biomass. However, in reality, agricultural waste such as rice husks and pine wood waste is still often simply burned in the open, polluting the air and wasting the potential energy it contains. In light of these issues, we present an in-depth review and innovative design titled The Potential of Rice Husk and Pine Wood as Raw Materials for Low-Emission Composite Biomass Briquettes. We offer a concrete solution called Pine Rice Eco Briquette. Why combine rice husks and pine wood? Let's examine their physicochemical characteristics. Rice husks are abundant and inexpensive, containing 35 to 45% cellulose and 20 to 25% lignin. However, its main drawback is its very high ash content, reaching 13.56 to 15% due to its silica content. If used alone, its combustion efficiency will be low, and it will leave behind a lot of ash residue. This is where pine biomass serves as the perfect complement. Pine wood contains a higher lignin content, reaching 28.85%, which provides natural binding properties and mechanical strength. Its ash content is very low, only 0.1 to 1.1%, with a high calorific value of 20.5 to 22.8 megajoules per kilogram. This composite synergy takes advantage of the abundant availability of rice husks while increasing energy density and reducing ash emissions through the use of pine wood. To establish a solid scientific foundation, we conducted a systematic literature review, SLR, in accordance with the PRISMA 2020 guidelines. From 63 initial references identified in reputable databases such as Scopus, ScienceDirect, and SpringerLink between 2015 and 2025, we screened and selected 32 relevant peer-reviewed scientific articles for qualitative and quantitative synthesis. Our critical synthesis identified 3 key production parameters that influence briquette quality. 1. Controlled carbonization, 300 to 500 degrees Celsius, consistently increases fixed carbon content and calorific value. 2. Tapioca binder, 10 to 15%, the optimal concentration that maintains a calorific value above 5,600 kilocalories per kilogram with adequate mechanical strength. 3. Compaction pressure, produces a briquette density of 813 to 1,014 kilograms per cubic meter that remains stable during storage. Based on this scientific evidence, we formulated the production process and prototype formulation for Pine Rice Eco Brick. The process begins with separate carbonization of rice husks and pine wood. The resulting charcoal is ground, mixed with a blend of 60% rice husk charcoal, 30% pine wood charcoal, and 10% tapioca binder, then molded into hexagonal shapes and dried until the moisture content is below 8%. This is what the Pine Rice Eco Brick prototype looks like. We chose a cylindrical hexagonal geometry with a central hole 10 millimeters in diameter. Why this design? The central hole creates a natural chimney effect. Air flows smoothly through the briquette's porous structure, resulting in complete combustion, minimizing smoke, and accelerating the heating rate. With dimensions of 50 by 40 millimeters, this briquette has a target calorific value exceeding 18 megajoules per kilogram and a compressive strength above 5 megapascals. We also conducted a feasibility evaluation using a SWOT analysis. Strengths: utilizes 2 abundant waste streams, has high calorific value, and is environmentally friendly. Weaknesses: requires initial carbonization energy and full-scale laboratory testing. Opportunities: high demand for clean energy among culinary SMEs, for drying agricultural products, and for outdoor use. Threats: competition with subsidized LPG, and fluctuations in biomass supply. In addition to evaluating the quality of each biomass type, we also conducted a critical synthesis of various previous studies. The results show that most research still focuses on a single aspect, such as optimizing carbonization temperature, binder concentration, or the use of only one type of biomass. In fact, briquette quality is determined by the interaction between raw material characteristics, production parameters, combustion performance, and product design. These findings form the basis for integrating all these aspects into a more comprehensive composite biomass briquette design. Based on this synthesis, we developed an evidence-based conceptual prototype that combines rice husks as the primary biomass source and pine wood as a supplementary material to enhance calorific value, fixed carbon content, and combustion stability. This prototype uses controlled carbonization, 10 to 15% tapioca binder, and a cylindrical honeycomb geometry to support more efficient airflow and combustion. Although it still requires laboratory validation, this design provides a strong scientific foundation for future development of low-emission biomass briquettes. As researchers, we acknowledge the limitations of this study, which is based on a qualitative literature review. Therefore, the next step is to conduct experimental laboratory tests to validate the actual calorific value, perform standardized CO/NOx emission tests, and assess the mechanical strength of the briquettes under SNI standard testing. In conclusion, combining rice husks and pine wood provides a sound scientific solution for low-emission composite biomass briquettes. Let's achieve clean energy self-sufficiency using local waste from our surroundings. We, the team from UIN WALISONGO Semarang, thank you.